Pi, not this one, but this one, is a magical mathematical constant. And in this video, I'm going to show you a way to estimate the value of pi by running a simple simulation using the Python programming language. So without any delay, let's get started. Okay, so before we start writing some code for creating a simulation for estimating the value of pi, we first of all need to know what we are actually going to do in theory. So what we are actually going to do is that we are going to do a Monte Carlo experiment. So what is a Monte Carlo experiment? So basically Monte Carlo experiments are actually a broad class of algorithms which rely on repeated random sampling in order to obtain some result. So what do you mean by repeated random sampling? Random sampling means that you repeatedly pick up some samples from any given population and then you analyze it in order to get some result. So that is what repeated random sampling is. And the basic idea behind Monte Carlo experiments is that you use the concept of randomness, or you use the concept of probability to solve some problems which might be deterministic in principle. For example, the value of pi is actually deterministic. We know that it is a constant, but we will be using the concept of probability to find the value of pi by doing some repeated random sampling. And now how is that going to happen? Let's see. Okay, so first of all, consider that you have got a square of side of length 2r like this, right? So we have got an orange square which has side of length 2r. Now inside the square, I'm going to draw a circle of radius r. So this is how it is going to look. We have got a circle of radius r. The circle is fitting perfectly inside the square because we know that if the side of the square is 2r, then the diameter will be 2r for the circle as well. So it is fitting it perfectly, right? So now we know that the area of circle is pi r square because the radius is r, and the area of square is 2r raised to power 2 because the side is of like 2r. So we get the area of square as 4r square. Now consider that this particular figure is like a dartboard. So if it is a dartboard and you can throw darts on this particular figure, then what is the probability that if I throw a dart randomly on this particular board, then it will fall inside the circular region? What is the probability for that? So by using basic probability techniques, we know that the probability that a dart, when thrown randomly without any strategy, will fall inside the circle and the probability for that is area of circle divided by the area of square. So that is what the probability is. So area of circle divided by area of square will give you pi r square divided by 4r square, which is equal to pi by 4. So we know that if I want to throw a dart on this circle or inside the circular region, if I throw a dart on it, then the probability that it will fall inside the circular region, it is pi by 4. So this is a probability that I know. Now consider that you also throw an infinite number of darts on this particular dartboard. So if you throw an infinite number of darts on this particular dartboard, then another way of saying that the probability that a dart that you throw on this particular dartboard will fall inside the circular region is equal to the number of darts which fell inside the circular region divided by the total number of darts that you threw on this particular dartboard. So that is another way of saying that. So there are two ways of specifying the probability. The first one was the concept of area. You divided the area of circle by area of square. The second way is if you are repeating your experiment infinite number of times, then it is number of darts which landed inside the circular region divided by the total number of darts thrown. So this is the probability. So now we have got two values for probability, one is pi by 4 and another one is this. So if we just put them together like this, we will get pi by 4 is equal to number of darts landed inside the circle divided by total number of darts thrown. Or we can simply say that the value of pi is equal to 4 times number of darts inside the circle divided by total number of darts thrown, right? So in this way we have actually created a kind of a Monte Carlo experiment where we are repeating some experiment infinite number of times so that we are able to achieve this formula where we can say that yes, the probability that the next dart that I'm going to throw will fall inside the circle is number of darts that I have already thrown inside the circle by the total number of darts that I have already thrown. but this is only valid if you have done it infinite number of times. Now, since we know that there is no value of infinite, you can repeat the experiment a large number of times. So as large number of times you repeat the experiment, the more accurate you will get. So you will get more accurate value of pi if you repeat the experiment a large number of times. So that is what we are going to do by running is kind of a simulation of this particular experiment by using the Python programming language. So let's get started with the code. So first of all, I am putting my dartboard on a kind of a 2D plane. So on the 2D plane, the center of the dartboard is at the 0, 0 position, and then the sides of the square will be, the edges will be at -1, 1, 1, 1, and 1, -1, and -1, -1, like this, because the radius has been taken as 1. So this is how my figure looks like. And now what I need to do is, I need to generate some points. I need to generate some random points which are between -1 to 1. Right? So the x value can range from -1 to 1, and y value can also range from -1 to 1. So in this way, I have to generate a lot of points randomly, and then I have to see out of those points how many of them will fall inside the circle. So how will you find that which point lands inside the circle? It's quite simple. You can simply find the distance of that point from the center. If that distance is lesser than the radius, then it means that the point is inside the circle. Otherwise, it is outside the circle. So let us try to code in order to create a simulation for this. So I'm just gonna import the random module first of all, because I'm gonna need it for sure. So what I'm gonna do is points is equal to, so I'm gonna generate some points. So how do I generate the points? So first of all, let me specify the number of times I want to throw a dart. So let's say I want to throw a dart 10,000 times. So for underscore in range n, so I am just gonna repeat this loop for n times, which is going to be 10,000 in this case, and I want to generate 10,000 points for that. So what are those 10,000 points going to be? You can find them by doing random.uniform. So random.uniform is a function which can provide you a random floating point number in a given range. So I'm just gonna put -1 to 1. So this is the x-axis value, and random.uniform -1 to 1 again, this is the y-axis value. So this is giving me a complete point, a coordinate, the x-axis value and the y-axis value. So in this way I can generate a lot of points. So let me see what points have I generated. As you can see, I have generated a lot of points which I can put on my dartboard. Now how many of these points are inside the circle? That is what I need to find. So points inside circle, points inside circle is equal to, I will have to check each point. So for point, or let me just put it like for x comma y in points, so I'm just gonna taking each point at once, and I'm calling that x and y, which means I'm unpacking them. So x is the first value, y is the second value. So for x comma y in points, I will consider it as a point inside the circle if there is a condition, if x square plus y square is less than equal to 1. So I am finding the distance between the point from the center. So that is given by x square plus y square. This is the distance formula, which is x minus 0 raised to power 2 plus y minus 0 raised to power 2. This gives you the distance from the center, and it should be less than equal to the radius, which is 1. So you will get that. So in this way I can get all the points inside the circle. So let us see how many points are inside the circle. So out of 10,000, 7,860 points are inside the circle, as you can see, right? So now as you can see that 7,860 points are inside the circle, and we have points which is 10,000. Then what is the formula? The formula was 4 times number of darts landed inside the circle divided by total number of darts thrown. So total number of darts that I threw was 10,000. The darts inside the circle is 7,860, and the final value of pi is 4 times length of points inside circle divided by total number of points into 4. That's it, and look at that, I get a value 3.144. So this is a nice estimation of the value of pi that I am getting, right? So in this way, I have created a very simple simulation in which I generated 10,000 points. I found how many points are inside the circle, and then using the formula, I found the value of estimated value of pi. But it is not quite accurate, right? Because it is 3.1415 something. Because if you just do import math and you just try to check math.py, you will get it like this. So it is 3.1415. So there is there is some difference, right? So we are not getting the accurate value. So how can I make it accurate? I can make it more accurate by repeating the experiment a lot of times. So now I'm just gonna improve my simulation by doing some changes to the code. So I'm just gonna create a function called run experiment. So I'm calling an experiment of throwing darts n times. So n default value for n is 10,000. So in one experiment, I will throw 10,000 darts and I will repeat those experiments so that I get more accurate value of pi. So for that, just putting the points here. After that, putting the points inside the circle here. And then returning the value of estimated value of pi from one experiment. So this is my one experiment. So let me just do it, run experiment. So we get 3.1296, again run. So look at that, I am getting some values which are quite close to pi because I am repeating the experiment 10,000 times. So as we can see that we are getting some values which are closer to pi but not exactly pi. So what can we do to make sure that we improve as we increase the number of experiments? So what I'm gonna do is that I'm gonna create an empty list which is called results. So results will store all the results that I get by running the experiments a lot of times, and then I will also store the error which is remaining now. So average pi. So let me just store the average pi values until I have run some results. Okay, first of all, let me do that. So for x for underscore in range, let's say 100 times. So let me repeat my experiment 100 times. So I will save all the results in my results list. So what I'm doing is I am repeating the experiment of throwing the dart 10,000 times 100 times. So actually I am doing it 1 raised to power 10 raised to power 6 times, right? So a million times. Also I will also find the average pi value that I get after I have repeated the experiment 1 time, 2 time or 3 time and so on. So the average pi value will be length of results, basically from each results, sum of results, how many results I have got, like this. So sum of results divided by length of result, basically the average pi value. So I will save that average pi value and I will append it to this particular list, average pi. So let us try to understand what is happening here. So in the results, what I am getting actually is some values which are quite random and are actually closer to pi, right? We are getting these values, and in average pi values what I have is, okay, so I had to divide it, I had to do simple division, not floor division. So in average, okay, so let me just clean average pi values first. Yeah, so look at that, the average pi values. So first of all, the average pi values was 3.1, but as we kept on going through the experiment, we are getting closer to the exact value of pi. We are getting closer, the error is getting decreased as we are moving, 3.141, right? So I am repeating the number of experiments and I am storing those results, and after each experiment I am checking the average of the pi values which I have accumulated till now, and I'm saving that in a list. Now how it will help me is that I can create a visualization now. So I can create a kind of a visualization. So what I can do is I can try to find the error which is remaining in my pi value. So average pi errors is equal to average pi errors can be written as absolute value of math.py minus pi, for pi in average pi values. So what I have achieved here is some average pi errors. So look at that. First of all, the error was 0.03, but if you look, as we went through the experiment, the error has become 0.0004. So as I am keep repeating the experiment and trying to find the average values, my error rate is decreasing. So just for making a good visualization of my simulation, I'm gonna do something like, I'm gonna make a plot from matplotlib, import matplotlib, okay, so it is import matplotlib dot pyplot as plt. So we will import this, and now it's time to plot. So plt dot plot average pi errors. So look at that, the average pi error. So initially the average pi error that I had was around 0.035, but as we increase the number of iteration from 0 to 20, then 40, 60, 80 and up to 100, the error rate has gone from 0.035 to almost around 0.000. So it is decreasing as I am increasing the number of iterations of my experiments. So if I just make it around 10,000 instead of 100 here, it will just keep on getting better and better. So the basic idea is that if you repeat this experiment infinite number of times, then your formula is as accurate as it can be, and you will get the accurate value of pi. So that's why if you increase the number of iterations of an experiment, you will get an accurate value of pi. So yeah, so this was how you can simulate this particular experiment, and I hope the concepts are clear. You can do it in a bit different way as well. So this was my take on it. So if you find this helpful, then you can like or share this video, and if you still have any doubts, you can put them in the comment section below. That's it from this video. Thanks for watching.